You don't need your Chromebooks. We're going to start with a summary, a review of what we did yesterday. So what did we work on yesterday?
Calculator.
Well, that was at the end of the day.
Functions.
We did talk about functions. That's what the first half of the lesson was on. So if we talked all that time about functions, that means y'all all know what a function is, right?
Yes.
What is it?
Input and output.
It has an input and output.
It's an order pair.
Okay.
It's a X or
X or Y.
you get what I'm saying.
Functions have to do with X's and Y's. Okay, so you see, here's an important part about math and school, but especially math. What I teach you yesterday is going to be relevant today and the next day and next year and the next year and any college classes you go to. Functions are a part of all of it. So yesterday is the only day that I am teaching specifically what a function is. We're going to deal with them all year, and I'm going to come back and ask this question all year for what a function is. So you need to learn what a function is, how it works. What was my example I used as a function? A Coke machine. And what had to be true for that vending machine?
When you press the button, a Coke comes out.
And it had to be the same product every time I pressed it. So does that maybe help refresh your memory of what a function is? The definition of a function? What is it?
When something has a map out to another thing. Like
Only one outcome, whatever.
Like when an input has only one outcome.
It's very close.
How close was it?
Very close. All right, so I'm going to do it again for the second day. And when I ask you on Monday what a function is.
That's a long time away.
And then on Tuesday, when I bring up, right, remember we talked about functions. What's a function? A function is a special relation. What's a relation?
Any set of ordered pairs.
A set of ordered pairs. Hey, we remembered that one. It's a special set of ordered pairs. Where?
Where?
Every input. Which variable is our input variable?
X.
X. Every input, every X doesn't have a output, has exactly
Oh, yeah.
one output. Inputs can have outputs. They can have multiple outputs. Remember, the button could give me any drink it wanted. That didn't make it a function. It had to be consistent. It had to have the same output every time. Every input has exactly one output. And in math, our output variable is the Y. But we have another way that we're going to write Y. That's the whole point of function notation. Instead of saying Y, we're going to now call it f of x. F of x is the same thing as the y. That entire thing means the same thing as y. But what I can do with f of x is I can tell you a specific value I want you to plug in for x. For instance, I could write f of the third button, if you think back to our vending machine. All right, I could just say f of 3. And I'm telling you what, go press the third button and tell me what the output is. What's the outcome? It's an easy way to write out what's happening instead of writing it in words. On the Canon Man, and you had to click and drag to 3 points. You guys remember that part? You clicked and dragged 3 points, and you had to explain to me in words what those 3 points meant. After 5.6 seconds, Cannon Man's height was 11 point whatever feet. And you had to say it out in words. We can write that much more quickly in function notation. I can just say f of 5.8 is 11.3.
Oh, didn't we do this?
We did. And it's a shorthand way to say the same thing much more quickly. Because as a math person, as someone who understands math, you should be able to interpret this. That's what we're working towards. Okay, that's the new goal for today, is we're working towards this function notation.
So all that stuff, those graphs we did had a reason. Well,
I like it. But you're right. Everything we've done so far has been for setting you up for what we're fixing to be learning. Now, the lessons weren't supposed to take as long as I made them take, but I thought it was really good material. And I thought it was really good practice for you guys to try to understand how to build a graph. Because so much of the ACT is seeing a graph like that and interpreting it, understanding what's going on. Any questions about what a function is? So, in this introduction to function notation, we're going to be given two different variables. How does that relate? Well, what happens in a function? We have two different variables. We have an input and an output. We have an x and a y. Another name for them is an independent variable and a dependent variable. So before we start working these problems, we need to identify the difference between independent variable and dependent variable. So what does it mean to be independent? It's on its own. That's one way to think about it, but it might confuse you in math if you think about it as being on its own. So let's look for a different definition of independent.
Independent can't change.
I'm going to tell you in just a second.
It can't change, right?
No, not necessarily. Give me something else that it means to be independent.
Solo.
That's still saying on its own. You're just saying on its own in another word. Why would you want to be independent?
so I don't have to rely on somebody else.
So that means, does that mean it's equaled out? Like if it's independent, like if F is on this side and something like no on the other side?
That's why I don't want you to think about independent being by itself. I want to change your mind of independent. I think of independent as being able to make your own decisions.
Well, you're a math teacher, so.
That didn't say anything about math. If you're able to make your own decisions, you are independent. If you can't make your own decisions, you're not independent.
I feel like
Your parents could leave you at home by yourself. That doesn't make you independent.
Oh, I still haven't burned down the house, but like, we ain't talking about that.
But that's why I wouldn't say on its own, by itself. People can be by themselves and not be independent. Independence is the ability for you to make your own decisions. So in math, I kind of think of it as the same way. The independent variable is the variable that we get to choose, that we have a say in what it is. And the dependent variable just depends on what we pick as our independent variable. So if we go through all of our definitions we have so far, we've talked about input and output. Which variable was the input variable?
It's X.
The X. That's what we put into the machine. That's what we're actually doing, is the input. We press the button. That's an input. And then the action, what happens after that input, is the output, which is our Y. So in that context, which of these variables do we have a decision on?
X.
The X. We get to choose the X. We get to choose which button we press. We get to make that decision. So the X, or our input, is the independent variable. Independent. While the Y is our dependent variable. Because what we get out of the vending machine depends on what we pressed. The Y, the output, depends on what decision we made for the X, or the independent variable. Questions there? So what we're going to do is we're going to be given different situations to start with. We're going to relate this more specifically to math in the second half of today's lesson and on Monday. We're going to really tie this into math. But to start with, we're going to put it in other situations, other circumstances. So if I look at number 1, these are 2 different variables, spring rainfall and wildflowers. One of these variables is independent. The other one is dependent. How can you tell which is which? The easiest way I've ever found to do it is I say 2 sentences out loud. And whichever sentence makes more sense to me is the way that it is set up. So this is what I would say. I would say the amount of spring rainfall depends on the number of wildflowers.
That's right.
Or I would say the number of wildflowers depends on the amount of spring rainfall. Now, which one makes more logical sense? Does the amount of rainfall depend on how many wildflowers there are? Or does the amount of wildflowers there are depend on the amount of spring rainfall? Number 2, wildflowers depends on rainfall.
Your sentence didn't help me there.
That's why you got to say it both ways. To say which one makes more sense. You can't just say one and say, yeah, that's it. Right? Logic through, and there's no easy way to do it. That's the best way to do it. Logic through, which one makes more sense. The other way they teach it is to say, is a function of. Is spring rainfall a function of wildflowers? Is wildflowers a function of spring rainfall? That's harder, right? That's not as easy to put in my head. So I use depends on. So in our case, the wildflowers depended on rainfall. So what we're going to do is we're going to label each one. We're going to say wildflowers is our dependent variable and spring rainfall is the independent variable. And then the sentence that I just said out loud that gives the relationship is what I want you to write underneath it or beside it, wherever you can. If you want to use another piece of paper, you can do that as well. But you need to say the number of wildflowers depends on the spring rainfall. The amount of spring rainfall. So you say the sentence or you write the sentence down. Do you guys understand what I'm wanting you to do? Identify the independent and dependent variables, then write the sentence that you use to decide which one was which. I want you to do it for 2 through 5. I'm going to give you 5 minutes. Okay, so when I look at these, look at on the left. You see how we have WC, T, T, AD, all the way down? What do these look like on the left? It kind of looks like f of x. How we've been talking about f of x problems. Instead of saying y, we're going to say f of x. This is the same idea. These are all just different ways you can say f of x if you don't want to use x as the independent variable. But when we write it as f of x, remember x is independent and x is what's in parentheses. So on all of these, what's in parentheses is our independent variable. It has to be, because in order to say f of x, this c is taking the place of where the x used to be. So C is independent. So what we're going to do then is we're going to write a sentence for each of these. So let me, last class I got confused. You're writing one sentence for each of these 10 problems. At least 4 of your sentences need to use depends on. At least 4 of your sentences needs to use is a function of. So for example, on number 6, you can say the number of calories depends on weight, or the number of calories is a function of weight. But you need to use each of those wordings at least 4 times. Does that make sense to everybody? And then that is all we are doing for the rest of the day. So once you get finished with that, if you're missing assignments, if you want to start working on the test you're missing, I don't remember how many I had in
You
here.
gotta do all 6 through 15.
Yep, all 6 through 15.